this is how to do beam plane for 2D by using a Connect version Staad Pro. So okay, at first what we're gonna do to take a coordination. So here I will take 3 and 2, 6, which is we can adjust after this. Then remove the grid. So I took 3.3 and 6.6 for x-axis. So my plane for 2D are done. And then next, go to the properties and take a define. This is for the section for this beam, which is I choose rectangle and concrete. So for the y 0.5 and z 0.25. Okay, sign and close. Then the thickness I use 0.125 and then add and close. So assign all the thickness and the define that I already choose just now. Okay, next is to for the support. So I choose support pin. I use pin support and then add and assign the support along the beam. Okay, then go to the load, and then there's a 2 types of load, which is dead load and live load. Then firstly add the live load, dead load. First I add dead load, dead load. Okay, and then add after that. I already add just now. Then live load to the next one. Add. Okay. There's 2 types of load. And then dead load. We assign add to the dead load, which is self-weight y-axis. Okay. And then I have a uniform load at the dead load. So the value is -3, and then add. This is if you want concentrated load. And then close. After that, for the we assign all the load just now we choose to the along the beam. See, this is the image. And then for the live load, which is also have a uniform load, which is mine. The value is -3. Add and close and assign along the beam. Okay, close. After done loading, one more thing, if I forgot, there's a combination load that we should add. Okay, the way is new, click the button new, and then load case and combination of load. First is SLS service. Then add the second one is ULS, which is to drag, and then for the LS there's a 1.35 for the dead load and 1.5 for the live load. Next add. Okay, close. After we done the load, all the load was assigned, and make sure that all the load was assigned to the beam. Okay, done. So we go to the analyze the data, by define, add and close. Run the analysis. Now we can run the analysis and see the result. If there is any mistake, there will be count. So there is no mistake. So proceed to pause. Here you can add what you want to show. As example, I want to show the member stresses added, and also add and member forces. All these things must be selected if you want the result. So what we're gonna do is find the command, and this is one of the step easiest way to assign to print the result. What you're gonna do, type here print member forces, and then print member stresses, and print the support ratio. So because I want this result, so I type this. Okay, and then finish and save the result. Exit. Okay. As you can see, there was a run the analysis, and you will see the result. The member stress result, member forces, and also separation. Okay. There's no error. Then you can see. From here, what you can see is the result. Okay. See, that's the result that was printed out. We put also the value, and then post processing. If you want to see the draw, you can click the post processing at the left, and then click the button. Want to see the result. See, there's a drawing of the load apply. Just you can see it's shear on y-axis, moment. Okay, so I try to add the value to see the value by click the button so that you can see the value. The maximum load on the beam at the center of the beam. Okay, then close. Can change also if you want to see. Other than the beam stresses, you can see the drawing of the beam stresses, displacement, deflection. Next, what we do is analyze again, and then we need to set the parameter for the beam. So this is one of the procedure. If the BS that we want does not does not in the list, which is BS0. See, BS that I want does not exist here. Therefore, I use the command line so I can type what I want. The way is, first type the parameter one. The parameter, and then start the concrete design and choose the code that I want to use. So I use BS8007, which does not there just now. So, and then for the spacing, by clear means spacing, I use 0.03, and then for the member 1 and 2. Okay, next is FY main yield is strength. I use 460,000, and for the member 1 and 2. Okay. Next, the last step, what you need to do is type the design beam for member 1 and 2. Okay, exit and save. So if the result was stated right when we run the analysis, okay, so no error, which means the method are right, the step was right. And then see the output. Okay, this is here the output of the beam. What you can see from here, there's a data here. Okay, I enlarge. Okay, here's the result of the beam. So the result is what we typed just now for the flexural and shear. Okay, as you can see, load design for the flexural and also data for the shear. This is for beam number 1, design result for shear. And then at the below, beam design for beam number 2, also flexural and shear. Okay, this is the data that we want. And okay, that's all from me. Thank you.